The purpose of this video is to review the volume of a cone, and specifically I'm going to go over the last three problems from the Clever assignment from last Friday. So the first one is this metal funnel, and it's asking us to find the missing dimension, which is the height, and it's asking us to round our answer to the nearest tenth. So in these problems, I'm always going to start by writing down the formula. So I know that the volume of a cone is 1/3 its base times the height. And in this case, it's the height that I'm trying to find. So when I'm looking for the area of the base, I'm going to, base equals pi r squared. And I have to be really careful about what they're giving me, if they're giving me the diameter or the radius. So this is the diameter because it's showing it going all the way across the funnel. So my radius is going to be 5 centimeters. So the area of my base is 25 pi. So my volume is going to be 1/3 times 25 pi times h. And the problem actually told me that the volume was 225 centimeters cubed. So I'm going to substitute in that 225. Now, I could certainly calculate 25 pi right now, but I actually like to keep it in terms of pi until the end of the problem, because then I'm not having to do rounding along the way. So the first thing I'm going to do is multiply both sides by 3. So I get 675 equals 25 pi times h. Then I'm going to divide both sides by 25. And I'm going to get pi times h. I don't know why I just made that a triangle. Pi times h equals 24, 26, 27. Let me just double check myself. I'm going 25 into 600. So that's 6 times 4 is 24, and 3 more 25s. So my height is going to be 27 divided by pi. So h equals 8.6. And I'm just going to double check that I'm rounding it properly. It says round your answer to the nearest tenth. So I have 8.6 centimeters as my height. On my next problem, I'm looking at a cone that is that I'm using to do lemonade, and it tells me that I have 10 gallons of lemonade to sell, and each customer uses 1 paper cup. How many paper cups will I need? And then it asks me about how many packages I should buy. So the first thing I need to do is figure out how many paper cups I'm going to need. So if this is my volume of lemonade that I need to sell, I need to figure out what volume will fit inside of this cone. So I'm going to start by finding the volume of that cone-like shape. So, and I'm always going to start by writing down the formula. My volume is going to be 1/3 times the base times the height. The base of this paper cup has a diameter of 8 centimeters. That's all the way across. So my radius is going to equal 4 centimeters. So my volume is going to be 1/3 times pi times r squared, which is 16, times 11, which is the height. So I'm going to simplify all of that. Get volume equals 184 centimeters cubed. So I just use my calculator to multiply all of that together. And then it tells me that I have 10 gallons of lemonade, and 1 gallon equals this. So that means I'm going to multiply times 10 to get 10 gallons. So I have 37,850 centimeters cubed. And that's going to equal 184 per cup times the number of cups. So I'm going to divide both sides by 184 and 184. So I know that x equals 37,850 divided by 184, about 206 cups. And I'm just rounding to the nearest whole number on all of these. So this is 206 The next problem asked me, the cups are sold in packages of 50, so how many packages should I buy? That's just going to be 206 divided by 50. And it's 4.11, so I really need to buy 5 packages, because if I only bought 4 packages, I wouldn't have enough. And I don't want to run out of packages before I run out of lemonade. And then finally, how many cups will be left over if you sell 80% of the lemonade? So if I sell 80% of the lemonade, then I'm using 80% of the cups. So 80% of 206 means that I need 665 cups. Again, each time here I'm just rounding to the nearest whole number. And if I bought 5 packages of cups, I would have bought 250 cups. So I'm going to subtract 165 away from 250, and I'm left with 85 cups left over for the next time I want to make lemonade. And then finally, my last problem related to the volume of a cone is this problem. A couple of these problems are pretty difficult, but I want you to be able to go beyond just writing down the formula and calculating it. I want you to be really thinking about what you're doing. So this problem tells me that the cylinder and the cone have the same volume. So I'm going to start with making my pen thinner. So that the volume of the cylinder is equal to the volume of the cone. So the volume of a cylinder I know is pi r squared times the height, and the volume of a cone is 1/3 the base, which is pi r squared times the height. So in the case of the cylinder, r they said is x and h is y. So I've got x squared times y times pi. Again, I'm going to leave it in terms of pi right now. I might have to calculate it at the end, but sometimes it makes my calculations easier as I work to keep it in pi as long as I can. And then the dimensions of the cone, 2x is the diameter, so x is the radius, which actually happens to be the same radius as the cylinder. So I'm going to put x for my radius, and my height is what I'm trying to figure out. So I've got 1/3 times pi times x squared times h. And I'm going to now just solve this equation. And I know it looks messy because I have all of these variables going on, but I'm going to be able to get rid of a lot of them right now. So I have x squareds on both sides, and I have pi on both sides, so I'm going to divide both sides by x squared times pi. And I'm going to divide over here by x squared times pi. So I'm dividing both sides by the same thing, which the division property of equality lets me do that. On this side, that cancels, so I'm left with y equals, again, cancel, 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 cancel. Y equals 1/3 h. So I have an answer, but I want to double check, do I have the right answer? It's asking me what is the height of the cone. So it's actually h that I want. So I'm going to multiply both sides by 3 to isolate that h. So the height of my cone is 3 times y. So that is my final answer on that problem. Again, really looking for you to be able to apply what you're learning, not just to crank through a formula, but to really think about how we can work with those formulas in relation to all the other skills that we've learned this year.